Uh-oh, if you're watching this video, that means you screwed up and you got a bad battery issue. So let's see what we can do to help you fix it. I don't know anything scientific about this. All I know is what works out of what I've tried here. I watched a ton of YouTube videos, read through a bunch of websites on technical write-ups on what happens with batteries, why they go bad, and how you can fix them, if you can fix them. And here's what I found. So a standard lead acid battery doesn't like to go below 12.4 volts. Below 12.4, it's considered not fully charged. And sulfation starts to occur when the battery is depleted. I believe it's below 11 volts is when that process starts to take rapid formation. And what happens is that buildup occurs on your lead plates inside your battery, and that reduces the battery's capacity, and if that stuff ever touches, the battery shorts out and then it's dead. So what we can do is we can use a couple different methods for a couple different scenarios. So first and foremost, you always want to keep your battery topped off. So you want to get a battery maintainer, and the best thing I've found so far is battery tender. This is the 24 volt unit. I found it as cheap as $80, but I've seen them listed on other websites all the way up to 200. So make sure you do your math on all this stuff. This is a great unit. It comes in this heavy duty aluminum case. It's mountable. It's made for some shock loading and vibration. It's made to go on heavy equipment and be plugged in 24/7 until you're ready to use that piece of equipment. Comes with a nice long power cable. It's got the ground prong. The only thing I don't like about it are these clamps. It's got the super cheap style of clamp. There's no serrations or teeth. They're smooth. These suck. I like to take these off, although these do have a fuse built into this. You can just unplug this here, because if you're going to leave it mounted to a vehicle, you're probably going to put ring terminals on and run that up. But for something short term, these came on my Menards charger. They have some really nice teeth. You can just plug that right in, because this is kind of a standard connection. The biggest thing is make sure red is still going to your positive, which is marked on here. Some of the cheap Chinese units will come reversed. This unit has settings for 12 and 24 volts, lead acid, AGM, and lithium. I don't do anything with lithium. I'm sure it's amazing, but it's well out of my pocketbook range. So you plug this into the wall without the battery being hooked up, and you pick your settings, and then you connect it. It turns orange once it's charging. If it's blinking, that means it's not charging. Once it starts blinking green, that means the battery's 90% full. Once it's solid green, that means the battery's charged. After that, it goes into a maintenance mode where it holds it above 12 volts. The only thing I really don't like about this is there's no readout for the cost of this compared to everything else here. Hands down, this should have a little display that tells you what the percentage of battery charge is. This thing is 5 amps at 12 volts and 2.5 amps at 24 volts. So it's bigger than most, but it's not like a super 6 amp charger. This is a 3 amp charger, 12 volt only from Menards. This is about 30 bucks. This is great for keeping a charge on a battery that's charged. It says in the instructions that if you use this on a car battery that's depleted, to charge it back up, you're going to reduce its life or its capacity. And that's true, because every big car battery I've charged with this that was down at like 50%, now the state of health on those is greatly reduced. Nobody can tell me why that is. I've asked like some battery experts, and they say, oh yeah, that'll happen, but they couldn't explain the science of it. So I don't know what the magic number is of amps to not damage or reduce capacity of a car battery, but according to this manual, at 5 amps, this one's enough to charge your car battery when it's dead. This has an LED display. It also works with lead acid, AGM, and lithium. It has a display that scrolls across and tells you the percentage of charge your battery's at. so you have an idea how much longer it's going to take to finish charging. Both of these are smart chargers, so if they don't see something they like, they will not put a charge out. This unit is Next Peak from Amazon. This was like 23 bucks. The reason I bought it was because aside from this $80 battery tender, this was the next cheapest and only available 24 volt charger that I could find. It also has the super cheap alligator clips that have the smooth edges. It's got an extremely pathetically short power cable. Everything else on this table has nice length power cord. This one has settings for standard, AGM, gel, wet, motorcycle, and repair mode. It's got this button. It's like not even really a button. It's kind of like the button on front of the old Xbox Ones that were kind of like motion sensing or whatever, heat sensing. It's kind of like your smartphone screen. The problem with this thing is two big things. The repair mode that's supposed to desulfate batteries doesn't do a damn thing. And number two, it shuts off after about 3 or 4 hours and doesn't go into maintenance mode like it advertises it does. So once it senses the battery's fully charged, it shuts off essentially. And I know that because I would run a inline voltage meter to check what this was at while it was off. So you can't just plug this in and walk away from it. It's got a cooling fan that kicks on. It's super light. That fan worries me because, you know, this cheap Chinese stuff is more susceptible for starting fires. Lots of cheap Chinese battery chargers have reviews where they've burned the whole vehicle and maybe even the house it was in to the ground. So this repaired no batteries. I tried it on over half a dozen batteries with 0 positive results. I charged up some 24 volt systems in my military trucks. It did work for that. So if you're just looking for the absolute cheapest way to bring your 6x6 back up if you forgot to turn your switch off, this will work for that, but don't expect this to work for desulfating a battery. I'm going to show you the Shoemaker chargers. These are 1.5 amp chargers. I used this thing for well over 6 years. This one weighs about 4 times as much as its replacement. They changed something inside this. The model number's the same, but they're clearly different. This one worked just freaking awesome. This one's a piece of crap. It died within 3 months. Come to find out, with the inline voltmeter, these overcharge the hell out of your batteries. I saw all the way up to 18 point something volts. You really shouldn't ever go above 15 is what I found out. And the 14s is probably the safe spot, but like 15 max. These would go up to 18. This is safe. This seemed safe. It did kind of this funky pulsing thing, but obviously it didn't work. This battery tender, 100% safe. The last kind of gimmicky looking thing I bought was this. It doesn't even have a brand name on it. I bought this because of another YouTube video. There's something scientific about the leads. I think this, supposedly the ground is actually too long. They're supposedly supposed to both be this short. The alligator clips it comes with, just asinine. How the F are you ever gonna get this around a battery terminal? Yeah, I don't know, but the good news is for $20, this has saved 3 out of 4 of my Optima batteries. So I had 2 red tops that were dead. It brought both of them back to life. And I'll show you some pictures here while I'm talking about it. So these guys were failing to hold over 12 volts, and put this on in line with the battery tender charger. The other chargers would all shut off. The battery tender charger though, I would put it on there. I would clip these onto the battery tender's alligator clamps. That's how I got these stupid little clamps to work. Otherwise you'd actually have to cut these off and put something better on them. All you do is make sure this little red light's flashing, and as you can see, my Optima red tops are both well above and beyond where they were when we started They're both now very close to the 800 amps that they're rated for. They hold over their 12.6 volts, and it's a night and day difference when you go to crank the vehicle. You can tell this saved me a ton of money, because Optimas have gone from that $140 to $180 range all the way up to double. Now they're $300. Tried this on a yellow top that was sick. It was just not at the state of health that it should have been. Put this on there, brought it all the way back up. It actually took it beyond its cold cranking amp rating. Tried it on a dead yellow top. It was too far dead. It wasn't even holding 4 volts when I started, and where we ended was it holds 11.88 volts all day long. I can power lights off it. It'll start a vehicle, but it'll never hold over 12 volts. I've thrown it on the ground to try to break up that sulfation on the inside. That's one trick. And I've tried the other method. I'll show you. I tried every method on this table. It will not hold more than 11.88 volts, so I consider it dead. Although in some of my lower requirement gas engine vehicles, it'll still crank those over. I'm going to say, just based off my experience, that this is only good for AGM, or specifically Optima batteries, because every single standard lead acid battery that I tried this on, it did absolutely nothing for. I saw no improvements from it. But like I said, for $20, saving me from having to spend $900 on new batteries, thank you, battery desulfator. As far as monitoring things, I've been using this voltmeter for over 14 years now. It's great just for reading voltage. That's about it. I recently picked up this battery health meter. It reads state of health, state of charge. It reads internal resistance in the battery, voltage. It can also read your alternator's output, and it can also read your amps that are flowing while you're cranking the starter on your vehicle. So I'll show you how this works. So with this guy, you just hook him up here, and you've got check, review. You can look at your last reading if you want. You go in or out of vehicle. You got this long list of different types of batteries. I don't know that this really changes anything. Then you've got the type of battery. So we're going for cold cranking amps. You can type in the cold cranking amps. The only thing it uses this for is to calculate a percentage for your state of health result. So you can make this whatever you want. If you make it something other than what the battery is, it'll just skew this SOH percentage, your state of health. So you have state of health, state of charge, resistance, the cold cranking amperage that's available, and its current voltage. And then it'll tell you, good, recharge, or good battery, bad, replace. I would completely ignore the verbiage on the bottom, but all this other stuff's extremely useful information. So what I do is I look at the cold cranking amperage at 688. This battery's supposed to be 800. So we're going to try this other method of charging. Then we'll come back and review what that CCA number is after this is done to see if this improves. So this is the method that I found by watching another really technical, helpful YouTube video. It's basically get a dumb charger. We're going to charge this battery for 48 hours. We're going to force feed it. So it'll charge up to 15 volts, and it's at a minimal amperage. This is a 6 amp machine, so that means it'll go up to 6 amps. After 48 hours, we'll disconnect our leads and check the battery. If it's below 12, we have to do it again. If it's above 12, we'll let the battery rest for 24 hours and check it. If it's above 12, then we move on. If it's below 12, again, then you have to go back to dumb charging it for 48 hours. Before you start, you need to remove your caps and check your water levels. If the lead plates are exposed, you need to add distilled water until the plate's covered. Don't ever fill above the funneled hole, because once the water level gets above that, it'll spill acid out. So I've put my battery inside a marine battery box to catch any potential spillage that comes out in case the battery is overfilled. For a sulfated battery, since some of that sulfur has condensed into a solid, you only want to fill distilled water above the plate to allow room when that sulfur becomes reliquefied for that fluid level to rise without spilling out. Keep a carton of baking soda on hand in case you have any spills. This is what it does to concrete when it spills. So to start with this guy, we're just gonna put our clamps on like normal. There's no hold feature on this, so I got vice grips to keep the timer on. I'm gonna plug it in. I'm gonna turn it on and watch for my amp meter to move. I'm gonna very briefly go up to the 150 amp starting feature to make sure that things are connected and working right. And as you can see, we got a spark here. Both my battery terminal and my clamp are corroded, so I'm gonna work that on. Try this again. So I'm gonna raise it up. If that needle doesn't move, or it barely moves, that tells me that this battery is probably not gonna be recoverable. However, if that needle moves up, that tells me the battery's taking a charge. And as you can see here, we were starting out with over 12 volts. This is a good battery. It's just at a lesser capacity than it should be. And I'm trying to recover some of that capacity so I can start my bigger diesel engines with this battery instead of having to replace it. If you're starting with a battery that won't hold 12 volts, you're going to have a lot more work ahead of you. Aside from my Optimas that were only holding 11 volts, I have not yet recovered a standard lead acid battery that wouldn't hold 12 volts. So if you get to the point where it's been 24 hours and your battery's holding over 12 volts, then you're supposed to hook up a 20 amp load and deplete the batteries down to 11 volts and time how long it takes. I use these KC highlights with 130 watt bulbs. I use 2 lights, and that's approximately 20 amps. It's close enough. So basically, hook the lights up, start a timer, and time how long it takes to get down to 11 volts. And it'll take 10, 20 minutes, maybe even 30 minutes to get down there. So it does take a while, but once it gets to 11, then it drops from there very rapidly, and you got to keep a close eye on it. Once you've depleted it to 11 volts, then you put a standard charger, whether it's your smart charger or whatever you want to use on it, recharge it, and then you'll repeat this process of putting the lights on to deplete it to 11 volts several times. He says do it up to a half dozen times, and that's going to be the max capacity you can build back into your battery. I'll show you a couple pictures of some of the lead acid batteries that I've played with. I've certainly recovered some cold cranking amperage capacity out of a couple. So far, 2 of them have had notable gains. In total, I've saved 5 batteries out of the 10 that I've tried to recover so far. I think that's pretty good odds. What I've learned is as soon as you find a battery's not holding its 12.4 or more volts, you need to get it charged back up. Keeping your lead acid or AGM battery above 12.4 volts or at 100% charge all the time is paramount for maximizing the life of your battery. If you're like me and you have the misfortune of not finding that your battery is below 10 volts until 3 months after the fact, there's a very high likelihood that you won't be able to recover it. Of the 5 batteries that I failed to recover, all of them had been sitting for an undetermined period of time, but it was at least in the weeks, most in the months, and 3 of them actually sat a full 10 months at their depleted charges before I was able to try this dumb charging method. The 2 lead acid batteries that I've been able to recondition so far were good batteries holding 12.4 or more volts, and I was just able to bring back some cold cranking amperage. The 2 lead acid batteries that I've been able to recondition so far were still good batteries holding over 12.4 volts. The other 3 batteries were all holding less than 11 volts. The reason we're using this quote-unquote dumb charger is because all of the other chargers will shut off if they don't detect, you know, a minimum of 11 volts or a minimum current transfer. This dumb charger will charge regardless. So essentially what we're doing with the dumb charger is we are giving it a partial overcharge where we're gonna get that battery acid hot, and it's gonna help break down that sulfation back into a liquid form. That's why if you overfill it, it will boil off liquid that'll spill out. Your battery's never going to come back to its full potential, but you can get pretty close. It's kind of your karma for letting it sit depleted. You're gonna lose something, but at least you can get some of it back. I'm told that no more than 6 amps and no more than 15 volts are the acceptable limits of this 48-hour charging method. I don't believe that anything below 4 amps will work for this because it may not be aggressive enough. You will notice that your ammeter will fluctuate once you start this charging method, and you want to wait to start your 48-hour timer until that amperage has become a steady, constant flow. So in conclusion, I would stay far, far away from Shoemaker. They obviously cheaped out and got rid of something that was really good and totally changed it up. But in either case, both of these were overcharging the whole time. So in reality, they were always bad. This Menards unit for 30 bucks, great unit if your battery's charged and you just want to put this on it while it's in storage and you're not using it. But don't forget, you can't use this to charge something up that's depleted. Stay far away from the Next Peak and anything that looks like it. There are several brands out there that look identical to this and just have a different little logo on it. They're all junk. This battery tender unit's awesome. Just make sure you don't overpay for it. If you've got a dead Optima, I definitely recommend trying this out. You really can't go wrong getting this little battery reader. So thanks for watching. I hope I've passed some useful knowledge along to you. This, like a lot of my videos, is the culmination of me watching all these videos, condensing it down, and trying to present to you exactly just the useful information, saving you from wasting your time like I have, sieving through all the worthless crap that's out there. So thanks again. Hope you subscribe, and we'll catch you in our next one.